First of all, take my greetings. I am Urchidash Oishi. I am starting to describe about first the topics name coordinate system, orthogonal curvilinear coordinates, and Cartesian. The first topic coordinate system. A coordinate system is a method for identifying the location of a point on Earth. Most coordinate systems use three numbers, a coordinate to identify the location of a point. Each of these numbers indicates the distance between the point and some fixed reference point called the origin. A coordinate system can be divided into three parts. They are Cartesian or rectangular coordinate system, cylindrical or circular coordinate system, spherical coordinate system. Here we can see these types. The first picture is Cartesian coordinate system, second picture is cylindrical coordinate system, and the last picture is circular coordinate system. Here we can see the requirements to define a coordinate system. The projection that is used to draw the Earth on a flat map, the location of the origin, the units that are used to measure the distance from the origin. The next topic is orthogonal curvilinear coordinates. Here we can see a picture where we can also see two sets of unit vectors. Here u is equal to u naught, v is equal to v naught, w is equal to w naught are level surfaces and also called coordinate surfaces. If the coordinate surfaces intersect at right angles, then the curvilinear coordinate system called orthogonal curvilinear coordinate system. Here we can see two sets of unit vectors, where number 1 define small e1, e2 and e3, and number 2 define capital E1, E2 and E3. The small one represents the unit vectors along the increasing U, V, W. And the second one represents the unit vectors along the normal of U is equal to U naught, V is equal to V naught, W is equal to W naught. These equations, we can come to know about the value of all unit vectors, where H1, H2 and H3 represents the scale factor. And delta U, delta V, delta W are normal vectors, which can use to define the unit vector. Now we can come to the third topic name, Cartesian coordinate. In geometry, a Cartesian coordinate system in a plane is a coordinate system that specifies each point uniquely by a pair of real number called coordinates, which are the assigned distance to the point from two fixed perpendicular oriented lines. Called coordinate lines, coordinate axis or just axis of the system. Here we can find any point x, y, z by the reference of the center 0, 0 and 0. Now, the last three topic will explain my team member Shushmita Dash.
Good evening. My name is Shushmita Dash and my topics are spherical, polar and cylindrical coordinate, change of axis and transformation of coordinates. First of all, spherical polar coordinate system. Here is the definition. In geometry, a coordinate system in which any point in three-dimensional space is specified by its angle with respect to a polar axis and angle of rotation with respect to a prime meridian on a sphere of a given radius is called spherical polar coordinate system. In the spherical coordinate system, the point in a space or in three-dimensional systems be represented by the symbol r, theta, and phi, where r is the distance of the point from origin or length of radial line, theta is the angle between radial line and z-axis, and phi the angle between radial line and x-axis. We can show the figure like that. Now, relation between spherical and Cartesian coordinates. The spherical coordinates are related to the Cartesian coordinates by r is equal to root over x square plus y square plus z square. Then cos theta is equal to z by r or equal to z divided by root over x square plus y square plus z square. Then tan phi is equal to y divided by x. Now, applications of spherical coordinates. Spherical coordinates are useful for describing situations that have spherical symmetry, such as a person walking on the surface of the earth. Moreover, spherical coordinate system is useful in problems with spherical symmetry like gravitational or electromagnetic fields. Now, cylindrical coordinate system. So, we can see from the figure a coordinate that is represented by cylindrical radius P, azimuthal angle phi, and height z is called the cylindrical coordinate system. In the cylindrical coordinate system, the point in space or in three-dimensional systems be represented by the symbol P, phi, z, where P is the distance of the point from origin or length of radial line and the zx in the x-axis. Examples of cylindrical coordinate system. Cylindrical coordinates are useful for describing situations with azimuthal symmetry, such as the motion along the surface of a cylinder. Now, relation between cylindrical and Cartesian coordinates. So, P is equal to root over x square plus y square. Then z is equal to z and tan phi is equal to y divided by x, where p is greater than equal 0, phi lies between 0 and 2 pi, and z lies between minus infinity to plus infinity. Height of p is equal to 1, height of phi is equal to p, height of z is equal to 1. Now, change of axis. The process of Changing the coordinates of point or the equation of the curve is called transformation of coordinates. Purpose. It is used to simplify problem solving and analysis by aligning axes with the specific features of the system. Now, transformation of axes. These are divided into three categories. They are translation of axis, rotation of axis, and translation of rotation. Translation of axis. In this process, the position of the origin is changed, but the direction is of coordinate axis is being parallel to the old system. When origin 0, 0 is shifted to the new point hk and keeping the direction of coordinate axis fixed, then the pair of equations x is equal to x prime plus h and y is equal to y prime plus h represents the relation between new system x prime y prime and old system xy is called the translation of axis. We can see that from the figure. Now, rotation of axis. In this process, the position of the origin isn't changed, but the direction of coordinate axis is being changed through a fixed angle with the x-axis, then this is called rotation of axis. The relation between new x prime y prime system and old xy system are given by x is equal to x prime cos theta minus y prime sin theta. Then x prime is equal to x cos theta plus y sin theta, or y is equal to x prime sin theta plus y prime cos theta. Then y prime is equal to minus x sin theta plus y cos theta. We can see that from the given figure. Now, translation rotation. In this process, the position of origin is changed and the direction of coordinate axis is being changed through a fixed angle with the x-axis. The relation between the new system and the old system are given below. X is equal to x prime cos theta plus y prime sin theta plus h, and y is equal to x prime sin theta plus y prime cos theta plus k. We can see this from the figure. Now, importance of coordinate transformation. It is vital in various fields, including computer graphics, robotics, and physics. Its applications enables working in coordinate systems that align with the problem at hand. So that's all for today. It was our presentation. Thank you all.